Hello everyone, it's me Varus, and in this video we'll be doing a full update on what's to come in winter, some early winter signs and teasers that we're already looking forward to this fall, this time of year. If you do like this video, please consider subscribing and liking. Let's get right into the video. So it's been a while. I did say I was going to upload this kind of winter teaser video a couple days ago, but I got stuck with a really bad fever, and so it's a little delayed, but here we are. I'm gonna try to get back to my uploading schedule, and yeah, let's get right into it. So first thing we always look at when it comes to winter is the ENSO forecast, the ENSO phase. Okay, and now most of these signs are signs right now that we're looking at, and then I'll talk about what's forecasted to come and how that will affect our winter, okay? So it's mainly just current analysis, okay? It's a deep dive into what the conditions are looking at like right now and how they could have impacts downstream. So again, here we are at ENSO, and when we look at ENSO, we see a clear trend. If you know what ENSO is, then that's good. If you don't, I'll give a quick little introduction. So ENSO stands for East-North or El Nino Southern Oscillation. Okay, it's a Pacific oscillation, and it's kind of near the equator-ish. No, actually no, it's a little north. But it's like this pool of water off the coast of South America, off the northwestern coast of South America, and so these waters have major implications for us in winter. So these values are important, okay? When you have a value that is above 0.5 Celsius, then you have an El Nino. If you have a value below negative 0.5 Celsius, you have a La Nina. In between, you get a neutral phase, okay? It could be warm neutral. Okay, I think I spelled that wrong. It could be warm neutral or cool neutral. Okay, and either one, I mean, if it was warm neutral, it would have more of a lean towards El Nino. If it was cool neutral, towards the La Nina. But that's typically what it is. And now when it gets below each of the values, so below negative 0.5 Celsius, it's officially in La Nina, La Nina territory. If it gets above 0.5 Celsius, it's El Nino territory. And then if it gets below negative 1, so in between 0.5 and 1 is moderate, and then in between 0.5 to 1 is weak, 1 to 1.5 is moderate, and anything further than 1.5, like 1.6, 1.7, etc., is we call strong, okay? And that applies for both El Nino and La Nina. So if we see the trend in the last few months, this dates all the way back to mid-June, we saw a spike up in the temperatures right to about July 9th, okay? It was around 0.0 Celsius, just a little below. Since then, we've had a consistent downtrend or cooling of the waters, okay? And sure, we've had these little spikes, but generally, when we look at the correlation, it's a negative correlation. And so you can see that we're near La Nina territory. We're in La Nina territory right now. As you can see, our latest value right here is negative 0.9. Now, this is the Nino 3.4. There's multiple regions like Nino 1 plus 1 plus 2, Nino 3, Nino 4, but this kind of is like the overarching index that we look at. So right now it's negative 0.9. So it is a weak to moderate La Nina that's kind of developing right now. And I don't have the forecast pulled up, but that's why I'm going to talk about it. It is expected to continue to cool through October, I'd say. And once it gets into middle to late November, or even all the way through November and into December, that's when we're supposed to hit like around the lowest. So that's when we're supposed to be in La Nina before we start to warm back up and get closer to cool ENSO neutral by the time we get later into January and especially February of the winter. So we could have various winter conditions. It could start off slower in areas and then end with a bang. It could start with a bang and slower and lighter in some areas, quieter, etc. That's going to be for when I do my winter forecasts, but just keep that in mind, okay? So ENSO is the thing I'm going to talk about the most because that's the most important oscillation, I'd say. Now, when we go to look at another oscillation, this is what we call a quasi-biennial oscillation, also known as the QBO. And this oscillation is another important teleconnection we look at when we're analyzing winter patterns and what effects they have. Long story short, we have a QBO in an easterly phase, which we call a positive QBO. If it was westerly, typically we call it a negative QBO. Last year we had a negative QBO. A positive QBO is in its easterly phase, and you kind of just read this graph bottom to up. So it stays in its easterly phase until about 55, and that's once it's like spring and past even spring, and then it goes westerly again pretty deeply, and I mean we can even scroll back up, and then it starts to get closer back, but it stays westerly. But through the winter, at least, we're expecting almost guaranteed to be easterly phase. Typically, I mean, I'm just speaking for the eastern U.S. because that's where I live. Typically, the eastern U.S. if you're a snow lover, you'd want more of a westerly phase. Easterly phase does bring more of a zonal pattern, even for areas of the western U.S. or central U.S. It's more of a zonal pattern rather than a snowier pattern. Western U.S. would want probably a positive QBO if you want more snowier weather. It's always vice versa. So that's the QBO, okay? Also has pretty important implications in winter. Now, PDO is another pretty important one. PDO is very important as well. It's Pacific Decadal Oscillation. Here you have a chart, okay? The blue is negative PDO, red positive PDO. And over the last, I'd say, 10 years-ish, we've constantly been in a negative PDO, and that does not look to change this year. It looks like it'll continue to stay in negative PDO, okay? The extremes in the PDO pattern are marked by widespread variations in the Pacific Basin, the North American climate, and it's in parallel with the ENSO, El Nino solar oscillation. So it has relationships to the ENSO, which is why we look at it through the winter. Negative PDO, still pretty important, okay? Typically, PDO can bring cooler air for the west, okay, or when it's below average temperatures in the North Pacific, it's a positive PDO. If it's above average, it's a negative PDO. And so if we do actually have an above average in the North Pacific, that actually may help the east with cooler weather. I'll show you guys that in a bit because there's another pattern that's kind of similar to this PDO that I'm watching out for. So next one, NAO, North Atlantic Oscillation, okay? Excuse me. All these patterns, by the way, are starting to end in oscillation, you know? So they're all teleconnections. They all interact with each other to produce different outcomes. So negative NAO. There's a positive NAO too, but let's talk about negative NAO. Because if you understand this, you understand a positive NAO. So negative NAO is when you have blocking or a ridge of high pressure in kind of the pit of Alaska. And what this does is it brings down cooler air, okay, from like the north and Atlantic Canada, brings it down, okay, and warms up lots of the west coast and typically the deep south, or more the southwestern U.S., okay? And then what it does is it lifts back north once it's typically off the coast or just lining the east coast. And what this does is, and I apologize for my sniffling. I'm still recovering from my sickness, but yeah. What this does is it yanks down colder air from the Arctic, okay? And that can be important because if you ever have a storm that decides to form, like a nor'easter, if you have cold air, you have it coming, you could get some big time snows along the east U.S., which is what I'm watching this winter. I'm not saying it's gonna happen, but there are signs that we could have some sort of chances, even if they never really occur. But there's possibilities that's favorable, okay? And I'll tell you why even more, okay? This is where I'm really watching right here, okay? Just south of Alaska. So, ridge of high pressure brings down that cold. You need that ridge of high pressure. If you don't have that, you'll either end up with a zonal pattern or maybe even a trough that happens here and brings a ridge into the east, which is what you would call a positive NAO. Okay, that's where you would have flipped, so cooler in the west, warmer in the east, or technically the eastern 2/3 of the U.S. Yeah, and then this also kind of correlates to Europe. For my Europe folks, if you have a weak low and weak high, here you get cooler or warmer temperatures further on in negative NAO, vice versa when it's positive NAO. Okay, so that's NAO. What's next? EPO. Okay, another pretty interesting correlation, important correlation with NAO. It's a negative East Pacific oscillation. Okay, also could end up with positive. Look, it's a very similar look to NAO. Okay, you get a ridge of high pressure south of Alaska, brings mild temperatures there, but it forces cold air down. Okay, and this forces really cold air down to the central U.S., portions of the northeast, portions of northern portions of the southwest, deep south, etc. This could bring cooler temperatures for everyone except maybe the immediate western coast. Okay, so that's what it does. If you have a negative NAO and a negative EPO, that's like the power buster combo for if you want a cold blast to happen. Okay, somewhere in the U.S., the lower 48. Now, there's other teleconnections as well, but those are the main ones. And then vice versa, when it's positive EPO, you get a trough until you get warmer or cooler in Alaska, and then a tall ridge building over the east. And these patterns are typically hard to break when they do get established, so that's important as well. Okay, now let's step aside from the oscillations and the teleconnections. Let's talk more about the current observations, what's going on right now. So, right here, it's kind of hard to see, but this up here is Alaska. This is obviously kind of like Russia, China, you got Japan, Taiwan. This is Asia, okay? This is Asia, this is Russia. Alaska. What I'm watching, this isn't the best picture, but there's this huge warm blob of water, okay? This huge warm blob. You know what? We're gonna do this on the fly. And we're gonna I'm gonna try to show a better look, okay? Okay, here we are, okay? This is what we're looking at. We have this huge warm blob of water situated south of Alaska and west of the west coast, okay? Here's our La Nina taking place, by the way. Right here, equator, so yeah, right along the equator. Maybe just north. And then, so you have this warm blob, okay? What does that mean? So in winter, this is probably going to change some by the time winter comes, because it's only September 17th, we still got about 3 months, or just over 3 months, till the official astronomical start of winter, okay? A little less than 2.5 months till meteorological winter. But overall, when you get warm blobs like this, especially this warm, this unusual, could be hard to break. Now, this is why it's important. When you have warm water here, you get lots of rising motion. And warm water, warm air, overall kind of encourages more of a ridge of high pressure, ridge of warmer air, higher heights, okay? What this does, again, when we go back to our NAO and our EPO, you see that ridge of high pressure, right? Sorry. That's the ridge of high pressure we're watching. So if this sticks around, this could amplify threats of warmer and ridging in this area, which would again force down cooler air from the north and would bend the jet stream and could lead to negative NAO or negative EPO. That's one thing we're watching, okay? So that's one ocean thingy I'm kind of watching right now. If we go further, I'm watching this other thing that's not many have talked about. So in the past, when we had Hurricane Aaron, if you guys remember, we had Hurricane Aaron tracked something like this, okay? Definitely not exactly like this, okay? But kind of went something like this, okay? Kind of went something like that, okay? So what it did is it kind of played a role. it sucked up a bunch of heat content, okay, along its path and even outside of its path. And so you got this cool blob. This is what I'm trying to focus on. This cool blob, cool, anomalously cooler water temperatures along the eastern seaboard, especially from like mid-Atlantic point south to the southeast coast. Now this is important because the last several years, this has been above average. Okay, this generally right here has been above average. Now, it's not too hard to recover from this. Like, it could definitely get warmer by the time winter starts. But knowing we already have cooler temperatures like this, it could be much more difficult. And even if it does recover, maybe neutral at best. Okay, maybe slightly warmer. So, in the past, whenever we had warmer temperatures here, if we, for example, had some sort of storm that, I'm not saying we had this like last year or something, but if we had a storm that kind of came like this and hugged inland-ish, or hug the coastline. If you have warmer area, it encourages the low to kind of strengthen, but it also helps to suck in marine warm air, okay, which would cause lots of areas just along the 95, etc., to switch to rain really quickly. Now you have a cooler blob, and so it helps to amplify storms further. It helps to restrict some of that warm air that gets into the East Coast, engulfed into the East Coast whenever you have a more inland storm, okay? I know this sounds really East Coast tailored, but I mean, I live on the East Coast. Lots of my viewers are along the East Coast, and so that's something we're watching. We're watching this cool blob, even if it just gets to average or even just slightly above average. That's important. If we get to these colors again, then it could be similar to last year. But if you get to like these whites or these light yellows / oranges, slightly deeper oranges, that's still important, a good play factor. So I'm watching this cool blob as well. We're going to monitor this in the next few videos and episodes. So that's about it. Went through most of the stuff. There's definitely other things I'm going to dive deeper into, like TNH, another oscillation, and other stuff that I want to dive into, but it's only September 17th. I'll probably have one of my first winter forecasts sometime in the first week of October. I'll let you guys know. But yeah, we're getting there. It's getting close. And so, yeah, I'll make sure to let you guys know if anything changes. And in the next few videos, I'll be starting to upload on the tropics, because some stuff to watch on the tropics. We have hurricane or tropical storm Gabrielle. I'm just going to sketch it here. It's somewhere right here. Gonna head out to sea. Could make a close pass to Bermuda. And then we have two disturbances out here that's kind of overlapping that we're going to watch. 20% generally moving in this direction. So I'll make sure to upload videos and update you guys with that as well. So again, I hope you guys enjoyed. I'll see you guys in the next one. And have a great rest of your day.